Assalamualaikum warahmatullahi ta'ala wabarakatuh and good morning to everyone. Welcome to the second chapter in Software Development Workshop. The second chapter is about object-oriented analysis using UML. This chapter is divided into 7 subchapters which are Introduction, then followed by Object, Class and Analysis class. After that is Class Diagram, then Class Relationship, then followed by Package, component diagram, and the last one is deployment diagram. As an introduction topic, we further divide it into 3 subtopics, which are object-oriented analysis and design, then UML, and the last one is diagrams in UML. Object-oriented analysis and design, abbreviated as OOAD, is a popular technical approach for analyzing, designing an application, system, or business by applying the object-oriented paradigm and visual modeling throughout the development life cycle for a better communication and product quality. Okay, get to know this topic. We would like to introduce to you the different terms between OOA, OOD, and OOP. OOA, we find and describe business object or concept in the problem domain, while OOD, which is object-oriented design, we are defining how this software object collaborate to meet the requirements, attributes, and methods, while OOP is the implementation part. In OOP, we are implementing the design object in programming languages such as Java, C++, C Sharp, and so on. All right, let's differentiate between OOA and OOD. Analysis is emphasized on investigation of the problem statement and the requirement of the system rather than the solution. For example, if we want to build an online attendance system, so we will analyze on how it will be used, what are the functions. Okay, analysis is a broad term, is an investigation of the requirements, or sometimes it is also called as object-oriented analysis or investigation of the problem domain. Meanwhile, design is emphasized on the conceptual solution, either in hardware or software, that fulfill the requirements rather than its implementation. For example, in design, we are describing the database schema. We are describing the software object required for the software to be developed. Analysis is the first technical activity performed as part of the object-oriented software engineering. And that's why OOA introduced new concepts to investigate a problem. It is based on a set of basic principles which are the information domain is model. Sometimes we're going to use use case diagram, for example. Then behavior is represented. In our subject, we are going to use sequence diagram to represent the behavior. Okay, then the function is described. That data, functional, and behavioral model are divided into uncover greater detail. Okay, the last step is early model represent the essence of the problem, while later ones provide implementation details. An analysis model created using object-oriented analysis is then being transformed to the object-oriented design into a design model that works as a plan for software development. OOD results in a design having several different levels of modularity. Example, the major system components are partitioned into subsystems. The system level is called modular. And data manipulation operation are encapsulated into object. The model form that is the building block of an OO system. In addition, OOD must specify some data organization of attributes and a procedural description of each operation. UML is the abbreviation of Unified Modeling Language. It's a standardized modeling language that consists of integrated set of diagrams. It was developed to help systems and software developers for specifying, visualizing, constructing, and documenting the artifact of the software systems, as well as for business modeling. The UML represents a collection of best engineering practices that has been proven successful in modeling of large and complex systems. The UML is very important part when we are developing object-oriented software and in the software development process. The UML uses mostly graphical notation to express the design of the software project. Using the UML, it helps the project teams to communicate, explore potential design, and to validate the architectural design of the software. Okay, speaking about stakeholders, who are the stakeholders in the software project? The stakeholders are such as analysts, designers, programmers, software tester, quality assurance engineer, our customer, software requirements engineer, and many more. Okay, all these people are interested in different aspects of the system, and each of them require a different level of detail. For example, a programmer needs to understand the design of the system and to be able to convert the design to the source code. In contrast, as a software requirements engineer, they are interested to identify the behavior of the system as a whole and need to understand how the product functions. Okay. UML attempt to provide a language so the expressive that all stakeholders can benefit from the UML diagram. Detail about UML can be found in the link provided below. Okay, there are 13 diagrams in UML. Okay, the diagrams can be divided into two types, either structure or behavior diagrams. Okay, structure diagram shows the static structure of the system and its parts on a different abstraction and implementation level and how they are related to each other. The elements in structure diagram represent the meaningful concept of a system. It may include abstract, real world, and implementation concept. There are 7 types of structure diagrams, which are class diagram, component diagram, deployment diagram, object diagram, package diagram, composite structure diagram, and profile diagram. Behavior diagrams shows the dynamic behavior of the object in a system, which can be described as a series of changes to the system over the time. there are 7 types of behavior diagrams. Okay, the most famous one is use case diagram, activity diagram, state machine diagram, sequence diagram, communication diagram, interaction overview diagram, and timing diagram. Okay, now we want to see what are the diagrams for each architectural view in 4 plus 1 architectural. Okay, as we know just now, we've seen there are several diagrams in UML. Each diagram has its own purpose or its own view. Okay, for example, for logical view means we want to see the system in a logical. We are building the class diagram, object diagram, state chart, and composite structure. To view the system in terms of process, we are developing the sequence diagram, communication diagram, activity diagram, timing diagram, interaction diagrams, and overview diagram. To view the systems from development point of view, we need to create the component diagram. All right? To see or to view the system from the physical point of view, we need to develop the deployment diagram. Okay, out of all, the entire view for a system is tied together in use case view. In that, we need to create the use case diagram and activity diagram. Okay, that's the end of the first part in the second chapter. All right, that's the end of the first part of the second chapter. Thank you for your attention.